Hello everyone, my name is David Taylor, and this is my protocol presentation for the Network Systems class. The subject of my presentation will be the domain name system, or DNS. DNS is a large, complicated system that has many moving parts, but it's also one of the integral parts of today's network infrastructure. DNS is not required for every network, but even in those networks where it's not required, you may want to consider using it because of the benefits that it provides. For this presentation, I'm going to give a brief discussion of what DNS does and its history. Then I'm going to walk through how it works. So let's start with what is DNS? What does it do? So I'm going to start by giving a little background about it. Right now, when some host wants to somehow communicate with another host across a network or the internet, for whatever reason, they have to have some way of determining the location of the receiving party. In our class, we covered how routers and switches work to send packets to the right destination and back. But fundamental to this operation is the ability to identify the sending and receiving host. Starting out, we have the data link layer, and at that data link layer, the switches use the MAC address of the host to identify the sender and the receiver. The switch uses this information to deliver the packets out the correct interface. A little bit higher in the stack, we have the IP address in the network layer. The IP layer uses an IP address to identify each host on the network. This is used by the routers to determine the network and where to pass the packet if the destination host is outside of the router's local subnet. This allows packets to be sent across multiple networks and even out on the internet, across the internet. So what's the problem? The problem is that for any task needing to be done on a host that needs to communicate with another host over the network, you have to identify the address of the recipient so that switches and routers on the network know where to pass the packet. Because IP addresses technically solve this, you can simply use an IP address to direct all traffic to the right host if you wanted to. The problem is that IP addresses are really hard to remember. So end users would have to remember the IP address of every website they needed to, the computers on the network, all of that stuff. And it's really hard to remember IP addresses. So for example, Google's IP address is 8.8.8.8. But do you really want to have to remember that? It's much easier to remember something else, like a domain name. Another problem is that IP addresses can easily be changed on the host at any point in time. When that happens, the end user sending the packet would have to know about the change so they can use the updated information. This introduces the question of how to easily communicate IP address changes. So, enter DNS. So how does DNS solve the problem? DNS solves the problem by working higher in the TCP/IP stack than the IP address. Our textbook references the TCP/IP model layers as services that higher levels can use. So a higher level utilizes the lower level almost as a service to provide that function for them. DNS sits at the highest level in the model, the application layer, and it essentially provides an abstraction to the network layer's IP address. It allows an end user to utilize friendly and easily remembered text strings called domain names to identify each host. Now, it could be debated whether or not domain names are always friendly and easily remembered, but certainly much more so than an IP address. DNS also is responsible for dynamically mapping those domain names to IP addresses. What this means is that if an IP address changes, as we discussed just previously, then DNS takes care of automatically mapping the domain name to that new IP address. End users don't have to worry about that kind of stuff. It's abstracted away. They don't have to worry about IP addresses at all. So quickly, to give you a little history of DNS, not a very long slide, but again, just a quick history overview. DNS specification was originally put into place in 1984 by Paul Makapedis, I think is how you would say that name. I apologize if that's not right, of the USC Information Science Institute. And it was put in place to solve problems that existed at the time for mapping hosts to IP addresses. I mean, that that problem has existed for years. So at the time, what they were doing was there was literally a single file called hosts.txt, and that file was maintained by a single central repository, and it didn't scale well. So DNS was introduced to solve the problem of how to handle domain querying as the internet grew. Later on, after it had already been implemented, it was updated, and there's some the most recent RFCs are newer than the original ones. All right, so down to the meat and potatoes. How does DNS actually work? So, as I mentioned, DNS is an application layer. It works on top of the transport layer and the IP layer and the data link layer and all that stuff, and it abstracts all of that addressing information away so that at the system level, all you have to remember are domain names. Now, IP addresses, of course, can still be used if you want to. It's pretty low level on the system and usually takes place behind the scenes. It's implemented like when you go to your browser, you don't have to worry about DNS. You don't even have to know what DNS is. All you have to know is that you type in the domain name into the browser window and it automatically talks to the right server. Under the hood, DNS uses port 53 to talk to the name server and get the information it needs. It uses either TCP or UDP as the transport layer protocol. UDP is what most people are going to think of and is the most common way of doing it, but it can be done over TCP to some degree. There are parts of DNS that actually have to use TCP. So again, it's an abstraction above the transport layer. It can utilize either TCP or UDP, even though UDP is most common. So what happens is the host system creates a DNS message. It then wraps that DNS message up and sends it on to the name server, utilizing all the lower layers just like any other kind of communication. So it sends out a TCP segment or a UDP segment, and it sends that using an IP address. All of that's involved. None of that changes by using DNS. But what happens is it sends a message across the network to a name server. The name server is then responsible for returning an IP address. Then, for any other communications across the network to that host, the system will use the IP address for that actual communication. What this means is that you'll end up with extra calls, so to speak. For every time you want to talk to another host, you have to have a call that reaches out to the name server, grabs the IP address for that host based on the domain name, maps it to the IP address, and sends the request using the IP address. So it essentially doubles your calls. But again, the advantages outweigh the costs. Plus, performance doesn't become a huge issue because caching is involved. So your local machine can actually cache information that DNS is using, and of course each name server can cache information, and name servers can sometimes have to call other name servers all the way up the chain until it finds the right answer. Okay, so I'm actually going to give you a quick demo to see a little bit of what that looks like under the hoods. Okay, so here we are. We are in Wireshark, and I wanted to show this to you. So what I'm going to do is I'm going to open up my browser, and I'm just going to do a simple web call to start page. I pulled it up. Now look in Wireshark. Notice all of these packets. So here we can see that under the hood, DNS is being used to query the information that it needs. And I'll show you a little bit about what these queries look like. So with this 192 address is me, and the 208.67.222.222 is the DNS server, the name server that's providing this information back to me. So let's take a look. We'll start by looking at me sending a DNS request to this ping.chartbeat.net. So here we go in the domain name system. We look and there's a query. And what I'm doing is I'm passing in the domain name that I'm looking for. So I'm saying, okay, I want to know what the IP address is for ping.chartbeat.net. And inside of that, just a little bit of information, tells it we're looking for a host address. Now let's take a look at the response. Notice the response looks really similar here. It returns what's called, now off the top of my head I can't remember what this is, some kind of record. And then here's our query again and an answer. So what it does is it gives us the address we were looking for, the domain name, and here we go. Here's addresses that I can use. These are all addresses to that same host. Okay, so here we've had a look at what DNS is, and that's pretty much it. There's a whole lot more that goes into it, including what's called resolvers that run on the host machine that are responsible for sending the information to a name server. And then, of course, there's a whole lot of information, a whole lot of detail, and a whole lot of complexity behind name servers and how they work, how the domain name system actually works under the hood. Here's some of the resources. Of course, our textbook at the bottom talks about this information. And there's a great book if you're really interested in this called DNS and Bind. Really a lot of great information there. And then here's a web address that I utilize for some of this. Thanks guys for listening, and I appreciate it.